Welcome back to part 2 of lesson 8-4. This second part, I'm going to show you how we can find the angles for right triangles using sine, cosine, and tangent also. So when we have something set up, let's say we have the sine of an angle equals its opposite side over hypotenuse. If I want to solve and find what that angle is, I need to get rid of the sine function on that side of the equation. So you don't need to write this down, but just really quick, let's review some inverse operations. If I want to get rid of addition, I need to subtract, because addition and subtraction are inverse operations. If I want to get rid of like squaring something, I need to take the square root, because squaring and taking the square root are inverse operations. If I want to get rid of division, say this is the problem, then I multiply, because multiplication and division are inverse operations. Well, it's no different for the operations of sine, cosine, and tangent. We need to do the inverse of whatever that operation is. And this is going to be hard to remember, but I think maybe you can do it. The inverse operation for sine is called inverse sine. I know, that might be tricky to remember. And it looks like this. So it looks like sine to the -1 power. What that means is that's just the inverse operation of sine. So whatever you do to one side of the equation to get that to cancel out so you can solve for angle A, you need to do it for both. And this is basically what you're going to be typing into your calculator. Some kids even like this one more, because once you remember that you have to just push inverse, it's usually less buttons to push in the long run. So follow me, I'll go through these next ones pretty quick. The inverse of cosine, let's say you wanted to find like the cosine of an angle, or you wanted to find the angle, you do the inverse cosine to get that to cancel out. And then lastly, if you haven't guessed it, if you have tangent, and tangent might look something like this, and these are just going to be numbers in the long run. If you want to get rid of the tangent function, you take the inverse of tangent to get it to cancel out. So when you're finding the missing angle, I'm going to write use inverse to find the angle. And most of the time, this is just the button right above your sine, cosine, tangent button on your calculator. It should look like, you know, sine to a -1 power, and I can show you individually, if you show me your calculator, if you can't find that, where that's supposed to be. So the next set of directions say use the calculator to find the measure of angle A. Well, angle A in this case, I have the opposite and the adjacent. So the hardest thing is finding out which sine, cosine, or tangent function you're using. So in this case, this would be tangent. So the tangent of angle A equals 6/20. And you can type this all into your calculator in one shot. You need to type in the inverse tangent, and you probably just need to put some parentheses around that. Depending on your calculator, you may or may not have to, so just make sure on yours you figure out which one you need to do. So I'm going to grab my calculator, my scientific calculator from the web, and clear it off. And I'm going to type in that I need to do second tangent. This actually ends up saying arctangent. That's another way you can say it. So if you see that, or here on this one, it says a tangent, that's just what that means. Probably on yours it's going to look more like the way that I wrote it. But again, that kind of depends on your calculator. So 6, where'd the division sign go? I think I need to get rid of second. Okay, there we go. So 6 divided by 20, and I'm going to put it in parentheses just to make it sure it works out right. And that is about 16.7, did the directions say? It's either going to be 0.7 or 0.70, and this is the way it should look. So the arctangent, or the inverse tangent of 6/20 is about 16.7 degrees. Let me go back and see what it said to round to. Yep, to the nearest tenth. So that would be my answer for that one. For this next one, finding angle A, don't let this throw you off. This is the hypotenuse because it's opposite from that right angle, and this one would be adjacent, so that's going to be cosine. So cosine of angle A equals the adjacent over the hypotenuse, and to solve that I'm going to do the inverse cosine so that I can find that angle. So grabbing my calculator, inverse cosine, let's see if I have a clear spot. I think if I put it down here. So inverse cosine of 3 divided by 15, just going to put that in parentheses, is about 78.5. So 78.5 degrees. And that would be my final answer for that one. Okay, and then lastly at the bottom here, the directions ask me to solve the right triangle. What that means is I need to find any missing side and any missing angle. And there will always be 3 things given to you, and then you need to find the other 3 things. And in this case, you're going to have the right angle because these are all going to be right triangles. There's some different methods you can use. You could use sine, cosine, and tangent for everything, but there might be something even faster that you could use to find something that's missing. So it doesn't really matter what you start with first. Let's say for this one we want to find the length of FH, and I don't have to use sine, cosine, or tangent for that. Actually, I can't unless I find one of those angles first, but I can use the Pythagorean theorem. So I'm going to set this up. 5 squared plus x squared equals 13 squared. You may recognize this as a Pythagorean triple. If you don't, it's not a huge deal. You can always go through and solve. But you're going to end up with 12 when you take the square root of each side. So I'm going to make just a little list over here. FH equals 12. You can put that on your picture if you want to. You can use that if you want to. I always like to go back to the original information though, just to make sure I don't make a mistake. So next let's find angle G. If I want to find angle G, I would say that this is the hypotenuse and this is the adjacent. So I'm going to write that this is going to be the cosine of angle G equals 5 over 13. And actually, while we're at it, let's go ahead and set this up for angle F also. For angle F, now the 5 would be opposite. So I could write the sine of F equals 5 over 13. And I'm going to just write those both down so when I go to the calculator, I don't have to keep kind of switching back and forth. So, on my calculator, I'm going to type in the inverse cosine of 5 over 13, close the parenthesis. That is about 67.3 or 0.4 degrees, but the question asked me to round to the nearest degree. So that's about 67 degrees. I'm just going to write that down quick and then type in the other one. So then for that next one, I'm typing in the inverse sine of 5 over 13. And that is about 23 degrees. So that will be important in just a second. So this angle is 23 degrees approximately. It's rounded to the nearest degree. I don't really like how they write that. I'd rather you round it to the 10th. But that's what the directions say, so we'll do it there. We'll follow the directions. Really, you didn't have to do that twice. I always kind of like to, just as a double check. But once you know 2 of the angles, you could always just add them up and subtract from 180 to find what that third one is. Again, I like that as a double check, but you see here that I found all of those missing sides, and in this case, all of the missing angles. So you could just make like a little list of those and, you know, put a box around it. For this next one, again, you'll have to use sine, cosine, and tangent for at least something, but I probably would find angle P first because I'm not going to have to use sine, cosine, or tangent for that. I would just add these two up to get 123, and then just take that away from 180. So that's going to be 57 degrees for that. And then let's call this one X, and we'll call that one Y. From this angle, we have the hypotenuse, we have the adjacent, and we have the opposite. I'm going to set these up, and then I'll use my calculator to do both at the same time. So if I wanted to find X, I would have the opposite and the adjacent. That's going to be tangent. Tangent of 33 equals 16 over X. And when I cross multiply, I end up with 16 equal to the tangent of 33 times X. And I could divide each of those by the tangent of 33. And I'm just going to leave that there for a minute while I work out the other one, and I'll type them on my calculator at the same time. So for the next one, this is the opposite and hypotenuse. That's sine. Sine of 33 equals 16 over the hypotenuse. So this one is going to be 16 equals the sine of 33 times y, or I could divide those each by the sine of 33 to solve for y. So I'll just grab my calculator, pull it up over here. Hopefully you can still kind of see it. I got a lot of stuff over top of it. Oops. Okay, I had to get rid of some of that stuff. It was kind of getting a little crowded. Okay, so I have 16 divided by, and I'm not doing the inverse here because I know the angle. I'm just doing the tangent of 33. So that is about 24.6, and it did ask me to round these to the 10th. And then the other one, I have to do 16 divided by the sine of 33. And this one here is, oops, did you get the stuff you needed? $29.4. So again, you can see I have all the different answers that I need. QR is about 24.6, and PR is about 29.4, and then that would be finding everything that I have missing. So we'll practice this in class, make sure you get the hang of it. I look forward to helping you then.